Page 24, least common multiple, the LCM. You want to find the least common multiple to be able to have like denominators to be able to add or subtract fractions. I mean, you could just have a common multiple, but that involves more reducing at the end. So we would find the least common multiple of 2 and 5. These are both prime numbers. So the least common multiple would just be multiplying the two together. That's 10. Let's look at 3x and 6. So we have 3, 6, 9. For 6 we have 6, 12, 18. The least number that they have in common is 6. And then they have an x. Because only one of them has an x, you're going to take the one with the biggest x's exponent. So 6x would be the least common multiple here. X squared and x, you want to take the x with the biggest exponent, which is x squared. To get x squared from x, you're going to multiply by x. To get x squared from x squared, you're going to multiply by 1. To get 6x from 3x, we'll multiply by 2. To get 6x from 6, we're going to multiply by x. Another way you can find the least common multiple is to do the cake method. So let's do that with 8 and 10. The number that divides out both 8 and 10 is 2. 8 divided by 2 is 4, and 10 divided by 2 is 5. Your greatest common factor is 2, and your least common multiple is 2 times what's left over after you can't divide anything else out. So the GCF is 2, and then the LCM is 4 times 5 times 2, which is 40. So the least common multiple for 8 and 10 is 40. How about 2x, x plus 3, and then x plus 3? Well, they both have x plus 3, so that's the GCF. What's left over is 1 and 2x. So we're going to multiply 2x times x plus 3 to get our least common multiple. So that's just 2x, x plus 3. You don't have to distribute it in for these. It's better to leave it in factored form so that you can use that to cancel out for wholes and vertical asymptotes later. Alright, so let's go on to the next part of the page. Set up the following addition, subtraction, fraction expressions. So we have 3x and we have 6 just like before. To get 6x, we multiply 3x by 2. So we're going to multiply these by the unity fraction 2 over 2. To get 6x from 6, we're going to multiply by x. So we're going to multiply the second fraction by x. That will give us 2 times 2 is 4. 2 times 3x is 6x. And then 5 times x is 5x. 6 times x is 6x. We don't have to write that again since they're the common denominator. So we can just put the 6x in the middle. So that's the same thing as 4 over 6x plus 5 over 6x. Let's do the last one here. So it looks like the denominators are relatively prime of one another. So let's just multiply the first fraction by x minus 8 over x minus 8, and then the second fraction by x plus 2 over x plus 2. So to multiply these two, at the top, we'll go ahead and use box or FOIL to multiply those out. Let's use FOIL in this case. So we have x times x is x squared plus x minus 8x minus 8. And then we have x plus 2, and then that's going to be subtracting. So we're going to also distribute the negative 1 into each of those. So we have minus x minus 2. And then that's all over x plus 2 times x minus 8. We're going to leave the bottom part factored for later. Combine like terms, so there you get x squared minus 8x minus 10 all over x plus 2 times x minus 8. It doesn't want you to simplify it from here. It just wants you to set it up. So we're done with this. Remember to set up two fractions added or subtracted to each other with the least common multiple. You want to find the least common multiple of the denominators. You want to multiply the first fraction by special 1. We'll say that this right here is special 1. The x minus 8 over x minus 8. That's a special 1. That's a unity fraction. And then we'll multiply the second fraction by the other special 1, which is x plus 2 over x plus 2. So if you divide them by itself, it still gives you 1. X minus 8 over x minus 8 does equal 1. It's just you'll use these special ones to be able to have like denominators, so that you can combine multiple fractions together. Finish the rest of this page and then move on to the next page.